And we are off. Okay, so today is the first lecture, topic 1 on whole numbers. And hopefully this will be review for you. If it isn't, be sure and stop me, and because I need to make sure that you understand the basics before we get into the deeper into the class. Okay, so what would you rather have, that number or, let's check, you can see this all okay, right? You should see a whiteboard on the right half of your screen. Okay. Or that number, because the number in the thousandth position is larger in the second case. Okay. So the objective is going to be as follows. We're going to look at arithmetic skills, why it's important to healthcare professionals. That includes addition, subtraction, multiplication, and division of tonight's topic, which is whole numbers, define order of operations, and how to round whole numbers to a specific place. So here is a place value chart, and this refers back to that first slide where we had those two numbers, and you can place those numbers in groups of 3 in the ones, tens, hundreds, and then ones, tens, hundreds, in the thousands, one, tens, hundreds, millions, on to infinity, off to your left. And like I said, review at this point. So you should be able to place those whole numbers on a place value chart. I see you nodding in affirmation. So there is one of those embedded videos, and that young man just basically goes through how to place 305,964 on a place value chart. So whole numbers are numbers including 0, 1, 2, 3 that don't have any decimal or fractional component to them. So 1/2 is not a whole number because it falls between 0 and 1. 1 is a whole number. 3.14, or the very beginnings of pi, is not a whole number because of that decimal point. 7 is a whole number, and 2017 is, of course, a whole number. So we're going to add, subtract, multiply, divide, and round, and become familiar with the terms sum, difference, factor, product, quotient, the divisor, dividend, and the remainder when you apply the above operators. So these are some various symbols that you will be expected to be familiar with. Let's start with the easiest thing, adding whole numbers. Let's stack those up. The addition property of 0 is, of course, 0 added to anything is just the number you've added it to. And it has sometimes been a little while since you've done long division or long anything. I know it was for me when I first started teaching this, especially long division. Stack the numbers and add them up. Carry the 1, 8,154. So when you're talking about the commutative property of addition, that means that basically you can rearrange any of the terms in an equation and get the same answer as long as you don't have any parentheses involved. So I think commutative, you're commuting, you're moving. That means you can move the terms within an equation. And the associative means you associate, means that you can move the parentheses around different terms within an equation that involves addition without changing the meaning of the equation and having the equal sign applying still. So addition and subtraction, are very similar. A term that is used sometimes is the difference. You're just saying subtracting the difference between 126 minus 99. 9 from 6 can't do it, so I need to borrow a 10 from over here. And 9 from 11 is 2. So the difference between 126 and 99 is 27. And long division, once again, is 18,345 minus 7,721. Okay, are you comfortable with long subtraction of whole numbers? Perfect. That would be just an example of that. So the third operator we'll look at is multiplication. Those are all different ways of stating you're multiplying the first whole number by the second whole number. So including the product of 9 times 11. Let's just do a long multiplication, 52 times 67. That third term there. 2 times 7 is 14. Carry the 1, 35 is 36. Indent 1, 6 times 2 is 12. Once again, carry the 1, 31. Once those terms are in place, add up those stacked numerals, get 3,484. Usually this isn't too challenging for anybody. And you do have the distributive property where you can distribute terms across. So A times the parentheses B plus C is the same as A times B plus A times C. So associative, commutative, and distributive. So there's the commutative property, A times B is the same as B times A. You can commute the terms around without changing the meaning of the equation. And the associative, you can move the parentheses as long as you're not changing the operators any place in that equation, and not change the meaning of that equation either. Now long division. So 125, the divisor and the dividend there. Or it can be written as 5 into 125. So 5 is the divisor, and 125 is the dividend. And the result of dividing 125 by 5 is the quotient, those two numbers. And so let's just set up a long division problem that comes out without a remainder. First of all, 125. 5 does not go into 1. 5 does, however, go into 12 twice. 2 times 5 is 10. Subtract the 10 from the 12, you get a 2. Bring down the 5, get 25. 5 times 25 is 5. 5 times 5 is 25. Of course, remainder is, you can put remainder 0 or just leave the answer as 25. And there, just to reiterate, you cannot divide by 0. Just for the lecture. So we'll drive 125 divided by 0. Cannot divide by 0 is the short answer. And then rounding, you are locating the digit just to the right of the place you want to round to. Once you find it, the appropriate place you're being asked to round to. If the digit is 4 or less, we place it in all digit to the right with zeros. The digit is 5 or more, replace it and all the digits to the right with 0 after adding 1 to the digit you are rounding to. That's just a long, drawn-out way of saying something like 2,844. If I asked you to round to the nearest hundredth, what would be the result of that? First of all, which digit is in the hundredth position?
The 8 is in the
Okay. And if I want, and then so to round that to the nearest hundredth, what would the result be?
Would stay, well, 2,800.
2,800, perfect. Okay, look at you're well versed in rounding, so excellent. I can go through that pretty quickly. I do run into students who need a little refresher on that sometimes, but I don't want to spend time on something you already know how to do. So I will just assume that you would be able to round to the nearest 10, the hundredth, and the thousandth. Do you want to practice that, or do you think, okay, you got that one down. Okay, great. So once again, rounding to the nearest 10, 100th, and 1,000th. So this is a summary of what we've gone over so far. Being able to assign place values to each digit in a whole number. Know what the commutative property is in addition. The commutative property in multiplication. The associative property in addition. And the associative property of multiplication. There's an example on line 6 of that. And be able to round any number to a given place. I'll be able to find the difference between two whole numbers, the sum of whole numbers, and the product, the result of division, and the quotient if you have to divide two numbers. Is there any of those you would like to circle back to and take a look at?
No, I think I'm pretty comfortable with all that.
Excellent. Okay, this is going to be a quick lecture. So order of operations. So do you remember order of operations from back in the day? Did you learn PEMDAS?
I did, yeah.
Okay.
Yeah, parentheses, exponents, multiplication, division, addition, subtraction.
Exponents, yes. Multiplication. And we won't be doing any exponents in this class. So, exactly right. So you work your way through an equation, ticking off each of these in order until you arrive at the final answer. Parentheses, exponents, multiplication, division, addition, and subtraction. You group multiplication and division together, and addition and subtraction together from left to right. So if we gave you something like 4 plus 5 times 2 using order of operations, what would the correct answer be?
It would be 14.
Okay, and how did you arrive at that?
Because I did the multiplication first.
So the multiplication was first, so 5 times 2 is 10. Okay. And then?
And then added the 4 and the 10 together.
Exactly. So once your multiplication is all done, you're left only with addition. And so the answer is 14. That is 100% correct. Perfect. So this is the long way to say the correct answer is indeed 14. 4 plus 5 times 2 is do the multiplication first, and then the addition is left, the answer being 14. And then if you use parentheses, sometimes, yeah, brackets, parentheses are interchangeable terms, or a fraction bar are all interchangeable ways of saying parentheses. Next to all multiplication and division in order, starting at the left and moving to the right. And finally, do all the addition and subtraction from left to right. Okay. All right. So let's do another example here. What would, let's stick with black. What would 5 plus 2 times 7 minus 1 be?
So we do 7 minus 1 first, so that's 6. And then multiplication. So then we do the 2 times 6, which is 12. And then the 5 plus 12, so 17.
Okay. Looks good to me. So 7 minus 1 is a 6. There goes the 6. 2 times 6 is 12. 12 plus 5 is 17. Excellent. You're a mathematical whiz there, Charity.
Just in the basic math department.
Yeah, well, it's good to get these reminders, and then you're kind of like you're kind of getting the field ready to do more advanced work in a little bit. So let's turn up the heat just a little bit more. 9 times 2 plus 36 divided by 3 minus 8. Using order of operation, what is the result of that whole mess?
Okay, so we do the 9 times 2 first. So the 18. And then the 36 divided by the 3. That's 12, right? Yeah, okay.
Yes.
And then the 18 plus 12, 30, and then minus 8. We got 32.
Hmm.
And then we got 32.
What? 30 minus 8?
33.
3 minus 8?
Well, I feel really dumb right now.
Oh, that's okay. We always have our phones with us these days, so.
Yeah, okay, 22.
Perfect.
There we go.
The important thing is you have the concept down. You knew exactly what you were doing. So
yeah, I was just on the spot. I knew exactly.
I guarantee you I'm going to do something just like that at some point. Someone's going, Mr. Mott, isn't, 99 divided by 11, 9? And I go, yeah, you're right. It is. Okay.
The basics.
Okay, but the concept is there. That's amazing. So 9 times 2 is 18. Walk through this. 9 times 2 is 18. 36 divided by 3 is 12. Bring down the 8. 18 plus 12 minus 8 is 22. Perfect. And that, let's just do one more. Make sure, drive this point home. So tonight, I kind of figure like PEMDAS is the big one, because that's the one that I always see on on social media when they put up, oh, do you know how to do this math problem? It always has to do with PEMDAS. And we have to agree on these basic rules of math. Otherwise, we're all going to get different problems, just like we have to agree capitalize sentences and end them with punctuation and all that stuff. Otherwise, it'll just be chaos. All right. I'll give you just you want to work through this one on your own, or you want to work through it in real time here?
Sure. I can work through it on my own, give you.
Okay. Tell me what you get. And then I will do that as well.
So 105. Oh, sorry. You're still going.
Okay. Okay.
Oh, I did it completely wrong. Never mind.
Okay, so let's just walk through it and see if you can see where maybe you went into the ditch there. So we have tricky part here. You have 2 sets of parentheses. Mm-hmm. So you start with the inside parentheses first. So So you have 3 plus 2, that's outside the parentheses. Inside the parentheses, you have 10 minus 3. Inside the inside parentheses, you have 5 minus 2. That's where you get that first 3 right there. Okay. And then we still have parentheses, so we need to do first the multiplication and division that are inside of that parentheses. So we have 3 plus 2 on the outside. We have 10 minus 3 times 3, which is 9. It's our next function that we perform. So we still have our parentheses we need to take care of. And in the next line, like 3 plus 2 times the result of 10 minus 9, which is 1. We've finally gotten rid of all the parentheses. Now we can just deal with multiplication and division, of which we have 2 times 1 being the only remaining multiplication. 2 times 1 is 2. Now we have taken care of all parentheses, all multiplication and division within those parentheses, all addition and subtraction within the parentheses. And then once the parentheses have gone, we have done the multiplication and division that is left. All we have left is addition and subtraction, with the final answer after performing the addition and subtraction being 5.
Okay, I found my error.
Oh, okay. Where did it go south on you?
Well, doing the other parentheses inside the other parentheses. So I did
inside and work their way out. Yeah.
Yeah, well, I got the 3, and then I figured, okay, you do like the 10 minus 3 and, get 7 and then multiply that together. But I didn't realize multiplied the 3 and the 3 together.
Rather than doing the multiplication and division still applied inside of that second set of parentheses. Yeah. I see. That makes sense, though?
Yeah, no, I got it now.
Perfect. All right, and that's all I have today. Any questions at all?
No, I think we're good.
Jolly good. All right, Charity. Thank you much for your attention and sticking around. I'd feel bad if there was no one here, so it was good for me. Do you have any questions about anything?
Nope, I don't think so.
Okay.